Hello, and welcome to today's webinar, an update on the STEEP Superfund. My name is Michelle Dixon, and I am the Program and Development Director for the Massachusetts Breast Cancer Coalition, and I'd like to thank you for joining us today. I am very pleased to welcome today's speaker, Dr. Rainer Lohmann. Dr. Lohmann is a professor at the University of Rhode Island's Graduate School of Oceanography. He has an undergraduate degree in biochemistry, master's in chemical engineering, and a doctorate in environmental science. Dr. Lohmann is the director of the URI-based Superfund Research Center on PFAS called STEEP, Sources, Transport, Exposure, and Effects of PFAS. He works in collaboration with scientists from Harvard University and the Silent Spring Institute. Dr. Lohmann, welcome.
Thank you, Michelle, and thank you to the Massachusetts Breast Cancer Coalition for inviting me. So I was asked to talk a little about the progress of STEEP, which has been operating for the last 4 years. So we have actually time to make some progress. So I'll spend a little bit on some of the research and a little bit on some of the implications that might be of interest to people on the Cape. So the funny thing is that I want to talk about PFASs, or in this case, shown as PFOA. Typically, it's very difficult to introduce a chemical to an audience, but in this case, of course, we have the luxury of having at least 2 movies already out that really only focus on PFOA, or PFAS as the main point of interest. So there's The Devil We Know, a documentary, and then more recently was a Hollywood movie, Dark Waters, with Mark Ruffalo. And both tell the same story of how a lawyer who was actually a corporate lawyer takes the case on behalf of a farmer who was a friend of his grandmother, and then successfully eventually ends up suing DuPont and getting a large settlement and a lot of insights into the dangerous effects of PFOA. So it's a very compelling story, and if you haven't watched either of them, please do. They can cover a lot of chemistry in a very fascinating way. The quick other background is these chemicals, they have a lot of fluorines, which gives them very unique physical chemistry. They're very strong surfactants. That explains a lot of their uses. And they repel fatty compounds and water, and that's why they've been used so widely. Of course, by now we know that they're basically everywhere in the environment. We also know that they're unfortunately in every US citizens, basically. And unfortunately, we also know that they cause adverse effects in humans and in animals. There have been some regulatory action, but mostly that was to ban PFOA, PFOS, and a few others. That's already in the early 2000s. So with that in mind, STEEP was founded to look into the sources, so where are the PFASs from, the transport, so what happens to them once they're in the environment, exposure, which was how do they get into animals, humans, and then what happens to them once they're in us or in animals, so looking at the effects of these compounds. And that's the Superfund Research Center in a nutshell, and we were glad to work with Silent Spring on Cape Cod, both as part of our research and as part of our community engagement. And if you haven't done so, please go to www.uri.edu/steep, and there you can see some of the latest developments of what we're doing. Something interesting that came apparent, and that's what Philippe Grandjean, our co-director from the Harvard School of Public Health, has been working on, and that was also covered in some of the movies, was the fact that the story of PFAS is starting somewhere in the 30s and of course extends to now, but there's a magical gap somewhere between the 70s and the early 2000s. And the magical gap is that before the 80s, some discoveries was made on PFOA and PFOS, and then nothing happened for 20 years. And only then suddenly were the compounds banned or phased out more appropriately. And so what happened is an interesting story of how science was not properly reported. And this is shown here, and it kind of ignore all the exact details. But there are several entries from the mid-70s to the early 2000s in gray, and those were not published. So even though there were some discoveries were being made, and they were often made by industry scientists, they were not published or shared with regulators. So people on the regulatory side, or the academic side for that matter, couldn't necessarily know that there was knowledge present that told of dangers of PFOA being able to pass through the umbilical cord, that there was evidence that PFOS transferred from the milk from, in this case, mother goats to baby goats, that PFOS was found widespread in the general population, that there are immuno effects. So all of this was known, but withheld. And that, of course, also resulted in delay of action on these chemicals. So presumably there is some link. And of course, that's what the story of the movies is also about. That explains some of the rather large settlements that have been agreed upon in courts. The other thing that has changed over the last few years, and since we wrote STEEP until now, is that the regulatory limits have been decreasing, and shown, this is here on the left for PFOA. Initially, I thought very high concentration of 10,000 or 100,000 nanograms per liter was safe. And then now we are down to where we think it's in the teens is a safe dose. And you see Massachusetts is right in there, and there's actually a bit of a misrepresentation, same for PFOS. Massachusetts numbers seem high just because Massachusetts actually will target 6 compounds together. So the sum of 6 should not exceed 20 or will not exceed 20. And that actually puts Massachusetts in a much more conservative regulatory setting than some of the other states. So actually Massachusetts is leading these efforts. But the good news is what we think is safe has decreased tremendously and is now around 10 nanograms per liter or so for some of these key chemicals. This certainly steps in the right direction. The other thing that we have worked on, this is from Project 3, Angela Slitt here, is the question, given that PFOA and PFOS have been banned, what else is being used, and are those better or worse than the chemicals that have been used? And it turns out, without reading all the fine print, that when there's a lot of red across all these entries, that suggests that even the new chemicals that are being used are just as potent as the ones that have been replaced. So overall, it seems that the replacement chemicals might be slightly different in how long they are, exactly how they're made chemically, but overall they are still potent as toxic chemicals. That's not a good thing. And then another focus we have was looking at what happens to these chemicals in wildlife. And it was known, this is a study from, or a summary statement from almost 10 years ago, that showed a lot of the North Atlantic, Arctic Ocean animals have really high concentrations. And if you go further south, there's very little. And we know that it's basically an effect that the small animals in the food web, so the plankton, the zooplankton, the worms, the clams, they typically have small concentration. Then as you go up towards big predators, be those birds, seals, bears, foxes, they have much higher concentrations. So we know this by accumulation, and of course that's also the reason why some of the humans are very high in concentrations. And we actually see some interesting differences between a polar bear and a fox. Part of that has to do with that it depends on how the compounds get into the animals. And there's both a question of what they eat, but also what chemicals, how they are transported. And we refer to some of these chemicals as precursors, and that is also important for humans. So that's why I brought this slide up. So we see both direct exposure through the chemicals as they are, but also through chemicals that can degrade to the PFOA and the PFOSs. So the project one, which is Elsie Sunderland's group, has been working both on seafood and the Faroe Islands, so in the North Atlantic, shown here on the left, and there you can start distinguishing between some of the chemicals that are consumed by the general population through seafood. You can see some other chemicals. These are the precursors that we think are taken up by the mothers and the infants or the children through products that are in the houses, in the homes. I'll get back to that a little bit later on. And there are some others that might be transferred through breastfeeding. So that's kind of the statistical differentiation between where these chemicals are from. And then closer to home, the same group has done some work on the Cape and seeing that some of the chemicals that you can see in the groundwater are certainly from the use of aqueous film forming foam, and others have some other sources, so some other uses that have caused some of the other chemicals to be present. If you're interested in this a little more, then there's a webinar coming up in just under 2 weeks, organized by the Silent Spring Institute. It's part of the series that's called Let's Talk About PFAS, the case of the missing contaminants. And that is Wednesday, June 23rd from 12 to 1, where Bridger Rule, the PhD student who worked on some of these results, will give a little more background to his findings. I encourage you to attend because that's going to be interesting. The other thing we've done, and this is work from my group now, is to look at PFAS in some other animals, and grad student Anna Robock decided to look at seabirds, great shearwaters. There's a picture of them. And the reason she chose these birds is because they're a bit like humans, I mean, except for the wings and some other minor differences, but they are global travelers. So even though you find them very regularly in Massachusetts Bay, you find them in Narragansett Bay, but you also find them further south. You find them in the South Atlantic where they breed. So they are interesting, long-lived species that integrate contaminants over decades. And she wanted to see how badly these are affected by PFAS. And so this is one of the results. And let me give you a quick, on the left, high concentration, that is in the Cape Fear River estuary in North Carolina. This is a known fluoropolymer production site. So there's an industrial region, and concentration are much higher. Then the next lot are samples from Massachusetts Bay, so offshore. So these are 10 miles or so away from the coast, and yet you still find a wide range of PFAS, the same as you find in Narragansett Bay. So we have this fairly consistent background of PFAS in birds that are really not land-lived, but they really are offshore coastal birds, but that unfortunately doesn't prevent them from accumulating these compounds. The other thing we noticed, or she noticed, in her samples is those birds from the Cape Fear, so that had relatively high concentration, actually also had much greater liver weights. And we assume that is linked to the fact that the liver is typically the place where the body tries to get rid of toxicants. And in this case, because of where these birds lived, they were trying to get rid of a lot of these fluorinated chemicals and probably other chemicals, and basically developed a much bigger liver to try to deal with that chemical onslaught on their bodies. So this is arguably not a good sign. The other thing, and this is a little more technical, but it's still relevant. So other than the fact that there were higher concentration in the Cape Fear region, there's also a couple of new chemicals that were present. And for those that like chemistry, those are shown here on the right. And one of them has the odd ability to actually preferentially get into the brain. Probably not a good idea. So luckily, these chemicals are mostly restricted to the region of the Cape Fear River. So she has not been able to find them in most birds outside. There are a few detections, but not many. So hopefully we will not have to worry about this on a wider basis, but just showing that some of these chemicals indeed have nasty properties. So the second part for me today was the question, so what do you do now? here probably some of you might say, yeah, we've heard this all the time, PFAS are bad, so what can we do about it? And I think one part that is important is, of course, to recognize that Massachusetts and a lot of the other New England states are working towards instituting fairly strict maximum contaminant levels in drinking water. But at this point, those are mostly designated for 5 or 6 of the most important PFAS that we are aware of. Question is, what do we do knowing that there's hundreds of thousands of other PFAS out there? And some of the scientists, regulators, NGOs working on this problem of PFAS have basically come up with 2 or 3 ideas. And one is to try to start grouping them so we don't have to look at one chemical at a time, because that would just take too long. The other is to treat them all as a class. And the last one is to think about it differently and say, which of these chemicals do we actually need? So which of these are actually essential for use? So let me quickly go through this. And this next slide, I'm sorry about it, it's a big mess. It just shows some of the possible ways we have to deal with a large group of compounds. And the easiest one, and that's probably the only one I'm going to spend any time on, is to say we can say if a long half-life, a persistent chemical is in itself a problem, then we can basically capture all PFASs. And that's what some try to do. But or we go through those chemicals that have the same action, have the same effects on the liver, let's say, on the immune system, and that's what the drinking water regulations are doing right now. So they try to work on chemicals that have a very similar modes of action. The other approach is to just say, and this is what a recent paper by these authors suggested, is PFAS should be just dealt with as one class. So you don't have to identify chemicals of concern with them. You just say all PFAS are within one group and we should deal with them as a class. That has is being tried in Europe right now. It has found some support in a recent bill in Maine. I think in California, this kind of approach was used for textile treatment. So there are very timid steps to deal with them as a class, but it's not yet widely accepted. And another approach, which is slightly different because it doesn't deal with the chemistry, the other approach is to say, well, maybe we can see whether we actually need them. So which of these chemicals are essential? And that was what Ian Cousins published. I was part of that group. And it's this concept of essential use. And the hope is that that can lead to some of the uses of PFAS to be just phased out. And so at this point, it might be worth stepping back and saying, well, where are these used? And particularly where are these used in household products, so where you and I could be exposed. And here's a nice set of pictures. I think that was assembled by the Green Science and Policy Institute, where you see really traditionally they have been in carpet and carpet cleaning products, in food packaging, particularly microwavable popcorn, furniture treatment, cosmetics, outdoor gear, clothing, adhesives, protective coatings. Of course, most famous, the non-stick cookware, the Teflon cookware, car seats, and of course, firefighting foams. And so the question is, could we have all these products without PFAS? And if we could, what would it take to actually get them without PFAS? It turns out the household products are probably the easy part of the problem. More difficult is that PFAS are used in many, many, many more applications. A lot of them are industrial. And there it is not quite as easy to know whether at any given point you can just do without PFAS. But that's basically the challenge for society. If indeed we want to get rid of or minimize the use of PFAS at every single application, you'd have to go into the detail and see what are they used for, are they needed, what else can we do to get the same benefit. So that's the challenge ahead, basically. So back to this idea of essential use. And the idea was really nothing new. It was borrowed or adapted based on the Montreal Protocol. The Montreal Protocol was the protocol that led to that was established in response to the ozone hole. And some of us who are a little older will remember that those were very scary times when we had, for the first time, realization that human chemicals were affecting our safety shield from UV rays from the sun. And so in response to that, a Montreal Protocol was established, and that did not ban every chemical that destroyed the ozone hole, but it said we ban everything except for those that are currently essential. And essential was defined as something that is really necessary for the health or safety or the functioning of society. Those are really big ticket items: health, safety, functioning of society. And so basically, to have an exemption from being banned, you needed to show that there's no available technical or economically feasible alternative present. At a really high levels, we're not talking about whether you can still ride your bike, but whether society will disintegrate, or whether people's lives will be harmed without having these chemicals in place. And so way back when, we had this ozone hole, particularly over the Antarctic, but it spread also to the other pole. And what happened is, after the Montreal Protocol was phased in, you did not see a complete stop of the use, but you saw a precipitous decline. And what actually happened in the protocol is the worst chemicals were phased out first, and those were the chlorofluorocarbons. And those were replaced by a not quite as bad HCFC, so that hydrogen. And so on you went through banning the worst with substituting with not quite as bad and restricting the uses. And then over the years, you see how it had a tremendous impact, and that basically we're down to very little use of any ozone depleting substance anymore. So the Montreal Protocol was a huge success, and that's probably good news given that we have major challenges ahead in terms of climate change and so on. So back to PFASs. Non-essential is basically something where the use is not essential. And so basically you can phase the use of PFASs out in these uses right now, and nobody will really notice. Examples might be dental floss, because there's plenty of dental floss without PFASs, water repellent shorts, ski waxes. So all of these uses, nice, but not essential. So if you ban them, nobody will really notice. A slightly more difficult category is the substitutable. So these are uses where PFASs have been, or PFASs were considered essential, but at this point alternatives have been developed, so we can actually still get rid of the PFAS because you have alternatives. And the examples that we have, luckily by now, is the aqueous film forming foam. They are now alternatives that do not use any fluorine, and they work basically just as well. There's also textile treatments that are without any textile and carpet treatments that are without PFASs, and maybe they're not quite as durable. They still work fine. So again, you can substitute, get rid of the PFASs, and you have no real major loss to any important consideration. That of course leaves the third group, the essential group. So these are essential uses where there's right now no substitution available, and they're really important for health or safety. And examples could be, I believe Teflon is used in heart stands. Clearly you want to have people get the stands when they need them, and if they're right now made of Teflon, so you keep using those Teflon stands. There's also certain medical protective clothing that has some PFASs in them. Of course, they should be used, but the idea is that you say, yes, they're essential right now, but give it 5 or 10 years, please do research, do innovation, come up with alternatives that are just as safe, just as functional, but are safer and have no PFAS. So that's the idea behind this essential use concept. Another example of category 1 is PFASs for some bizarre reason were used in cosmetics. And really there's no need. And luckily some of the retailers have noticed that, and there's some action underway to indeed have PFAS-free cosmetics being offered on the shelves. Another example that is a little slower, but it is coming along, is the use of PFASs in outdoor clothing. Often they have something like a Teflon breathable membrane in them. And by now, alternatives have been developed, and some of the higher brands, higher as and more expensive brands, have phased out PFAS. And if you look at the labels, some say PFAS free, some might just say PFOA free, but certainly those moves are underway. And with a little bit of search, you can find which ones are good to use. And that, of course, leaves, as I said, there are some essential uses. Firefighter turnout gear right now is certainly essential, even though the firefighters are certainly concerned about what exposure they get from both the gear they have to work with and the chemicals they use to extinguish certain fires. So this is a good area for research and innovation. The other thing, and that's just a general point for PFAS and these Teflon-like chemicals, there's a lot more going on to make the Teflon. And once we have Teflon in the households, typically it doesn't react very much, it doesn't degrade. But until the point that you have it on the supermarket shelf, there's a lot of emissions and have a lot of concerns about what happens. So the whole concept needs to be a little broader than just saying, is Teflon safe to use when it's in your frying pan? Okay, so with that, I want to get back to those slides. So these were the uses that we know where PFAS are used in household products. And the good news is that at this point, basically for every single one of these uses, you do not need PFAS anymore. They have been phased out in textiles. In carpet, certainly there is outdoor gear that does not have PFAS available. There's a lot of brands that never carry PFAS and others have dropped. And there's film forming foam without fluorine. So the good news is there's a lot of development to say none of this is really necessary. So then the question is, how do you know about this? And there are some brands, and I can just list a few here. And I don't want to endorse any of them. I just noticed that some chains like L'Oreal, H&M, The Body Shop, and so on have phased out PFAS. You can find normal ski waxes without. You have find alternatives instead of Teflon frying pans at home. So all of those alternatives exist. And some of the bigger retailers have already phased out PFAS. Unfortunately, a lot of those are from Europe, so that's not quite as useful, but some of them, of course, sell in the US anyhow. And I'm pretty sure that some of the US retailers are also working on this as we speak. But if you're interested in finding out more, there's a website at the pfascentral.org/PFAS-free-product. That's going to be very useful because they can actually see a listing of companies or retailers or producers that actually sell PFAS-free products. So there's a growing body of evidence that suggests what you can use if you have the time. The other way is to look at, there's this retailerreportcard.com, and that is a slightly bigger picture view of looking at how retailers deal with the toxic chemicals that they have in their products. And it's not just PFAS, it also covers solvents, heavy metals, and so on. But it's a good idea because it really rewards those retailers that take an action and try to be protective of their consumers and workers. So if you look at the retailer report card, you find ratings for different companies, and some care more, some care less. And hopefully over time, given public pressure, more will be in the camp where they try to be proactive and active about chemicals. Of course, the question is, where does this lead you and I? And yes, in theory, it's always the consumer rules, but in practice, it's almost impossible to know exactly what you're going to buy. So yes, we have some choice, but probably equally important, some of the NGOs are very vocal and very aggressive and impactful by targeting retailers, producers, say, please phase out X or Y, otherwise you'll be in trouble. And that seems to work, because given that often the regulators are slow for various reasons, working with retailers and producers seems a very effective way of avoiding exposure or reducing exposure for consumers in the first place. Of course, you can work with your town, and I think Barnstable certainly is trying to be doing the right thing by looking into what they purchase, for example, when they said they're going to buy a new AstroTurf. And then, of course, the states, and Massachusetts is pushing ahead. Hopefully, eventually, EPA will catch up. It's always a bit difficult to know. And then, in theory, there's also international conventions, but they are even slower to be negotiated and trickle down to the national level. But I think we basically need action on any and all of these at the same time. And so with that, I don't want to bore you to tears. It's a beautiful day. So thanks everybody who found the chance to listen in. Steve, we're working on our renewal. We hope to be on the Cape for a few more years. We'll start looking more into marine food and biota to see what we can learn about what happens in food webs. We'll also start thinking about exposures beyond just drinking water, realizing that drinking water is a very important uptake pathway, but it's not the only one. So to see whether there's anything else we can identify that could be substituted easily in homes to help everybody. And then, of course, the last question is, how do we deal with all these PFASs, and can we move towards where maybe they're considered as a group or as a class? And that way, we don't have to spend all this time figuring out if these 10, 20, 30, 50, 100 chemicals are all equally bad or some are not as bad as others. So with that, I should thank those that entrusted us with funding, and you, of course, for listening on this beautiful day. Thank you.
Thank you very much. Well, we do have a couple of questions. From an international standpoint, can you speak to the differences in the regulatory process that may or may not be happening on an international level versus what's happening here in the States?
Yeah, a little bit. So in probably the most exciting development, if that's the right word, for legislation is that the European Union is trying to work with the idea of essential use within their chemical strategy. So they're evaluating whether they can indeed phase out PFAS based on the lack of need, if that's because they're not essential. That would be the first time in a big international arena and for a big market. The other thing that is also discussed in Europe as part of their water framework is whether you can regulate PFAS as some. It's an interesting way it is phrased, and I'm not sure I get it completely right, but I think within the European Union, they say there's a 2-year window within which it will be explored whether you can use a total organofluorine method for testing water. That would be revolutionary, because that would actually require you don't have to know exactly what chemicals are in there. You just say, is it more than whatever concentration they give? And then you have a problem, or if it's less, then it's safe. So that would be the first, and you actually measure them as a class. So both of those are happening in Europe. I don't know, the outcome is unknown because it's going on right now, and certainly there will be discussions and pushback or negotiations, but that's certainly happening there. On the international, the Stockholm Convention has taken up several PFASs, and I think it's actually taken up more now than the EPA has regulated. But to the best of my knowledge, the US has not ratified the Stockholm Convention, so the agreements are not binding for the US, so that actually doesn't help. And I think that's unfortunately all I know.
Can you tell us a little bit more about the future plans for STEEP on the Cape and beyond? Will you be studying in other areas?
Sure. Now, of course, this is all dependent on what our esteemed peer reviewers think of our application. But what we have outlined in the next 5 years is to actually have to shift the focus away from drinking water, because we have already done a lot of private well water testing through STEEP, And luckily, most of these results are very good, as in the detection is very, very low. But we want to take a closer look at PFAS in food items, both homegrown produce and fish, shellfish, and then also at some of the chemicals that might be used indoors. So we want to look at indoor air quality for PFAS. So that's the big focus on the Cape, and we'll keep our effort on the Faroe Islands, where Philippe Grandjean has been working for decades. So that would be continued, and we'll have another focus on better understanding the enrichment of chemicals through food webs. So that would then end up being in the fish or in the birds. And lastly, we'd start to include a few other sites beyond the Cape, not because the Cape isn't the most beautiful site, but there are some other sites that have even more pressing needs, and that's often sites where there is industrial manufacturing happening. And I think we've now realized that these chemicals can also be transmitted through the atmosphere, so the spread of them is wider than we once thought possible, and that raises all kinds of questions. So that's kind of some of the elements of the renewal.
Well, actually, you've just touched on the next question that's come in. We understand, what are the implications in terms of how PFAS is being spread through the atmosphere? Is it airborne, and is it concentrated to particular areas? Is there research in that arena at the moment?
Good questions, always those. I'm not sure I know the good answer. So let me try. There have been some indirect evidence. A study led by some EPA scientists in the, I think it was in the Delaware region, where they looked for some novel PFASs, and they found them in soils over a much, much wider region than was thought possible, because typically we think of PFAS as being bound to water and flowing with the water. And this spread was much more in line with an atmospheric dispersion model. And to some degree, we know there was some atmospheric component, because some of the uses of Teflon involved a drying step, and I think that might have contributed to the spread of PFOA in Hoosick Falls or Bennington. So we know there was something, but we just thought it was very regionally constrained. That might still be the case. It's just very, very few people have measured PFAS in the atmosphere. Now, having said that, I think on the outdoors, the concentrations are going to be very, very low. So outdoor air is not going to be a big problem for human health, but on a local scale around a manufacturing site, industrial place, there might be some concerns.
And is there any study, anyone looking at, to the best of your knowledge, the impact that PFAS is having on the immune system as it relates to COVID?
Yes, I'm only aware of sorry, let me backtrack. I know there are several studies that look at this because it seems an obvious, timely topic where we know one of the effects of PFAS is on the immune system, and of course we know a weakened immune system would be an invitation for COVID. So yes, I know there are studies. I'm only aware of the one that has been published by Philippe Grandjean. He found some link between higher PFAS and more susceptibility to COVID. But as always in science, you really need several more studies to confirm that that is indeed a firm result. So, but from everything we know, yes, we have to fear that those that have the problem of a high exposure to PFAS are probably more susceptible because the immune system will be weakened.
And I know you did touch on this, but if you could just circle back for people who are concerned about identifying PFAS in their own homes and what to do about it.
Right, so I think the best thing I would say is go to this website here at the bottom, pfascentral.org/PFAS, /PFAS-free-products. and take a look. Depending on what you buy anyhow, there are of course natural products, whatever they're called. They probably never ever had PFAS in them. Certainly not knowingly. But by now, a lot more retailers have paid attention. So go to that website, or you can probably also Google, I assume, PFAS-free products, and you would probably find this link and look through, and that might help you with some of the purchasing decisions if there's something that you have to replace.
Great. I'm going to give it a minute and see if we have any other questions. All right. Wow, Dr. Lohmann, thank you.
Well,
On behalf of Cheryl Osimo, MBCC's Executive Director, and our Board of Directors, I want to thank you for giving us this update today. And I want to thank all of our attendees for joining us this afternoon. For those who are interested, the recording of this presentation will be available on our website later this afternoon at mbcc.org. And with that, I want to wish everyone a good afternoon.
Thank you. Same to you.
Thank you. Take care.